What's up, CMS? It's your boy, Mr. Conaway. Welcome back to this. Sorry, that was ridiculous. You can go ahead and acknowledge that. All right, hey guys, we're going to start a new assignment. And so for folks that are not part of my class and are just following along with these videos to learn how to use an Arduino, I'm just going to show you what the assignment for my class is. So it's this assignment number 3, and it's called Blink One Light. So here's the instructions for the assignment. Number 1, watch the video that you're on right now. Follow along in your own Tinkercad as instructed. So we're going to build something together. Today I recommend you watch what I do. Hit the pause button, flip back to your Tinkercad tab, and construct what I'm building there. Step number 2 is when you finish building the Arduino project like it's shown in the video, submit the public link to the project right here. So this is only obviously for folks in my class. And step number 3, this is the big part because this is our goal. And this project will get one LED to blink on and off using an Arduino. You should be able to tell me how to use the following when you're finished. That's the int or the int, the variable data type, the pinMode command, and you can see the arguments that we pass through pinMode. digitalWrite, and then you can see the arguments we pass through digitalWrite, and then the delay command, and then the arguments we pass through that. We're going to talk about all these things in a little bit more depth today. But let's go ahead and get started. So I'm going to flip over to my Tinkercad. I'm right now in 3D Designs. I need to change that to circuits. And I'm going to create a new circuit. Alright, so here is my new circuit. Ooh, that's kind of interesting. I've got a new component here, micro-bit component. I'm going to have to check that out later. Anyway, back to our task at hand. This is assignment 3, so if you are in my class, remember you do have to rename these to match the assignment. So right now, you should, after I do this, maybe pause your video and then go here and type in Arduino assignment 3 right there. Sorry for the notification, guys. Alright, so you can see it's Arduino assignment 3. That's what yours should say. So if you need to pause now and make yours say Arduino assignment number 3. And then moving on here. Okay, so this is just like building any other circuit. So let's bring in our breadboard. We will need one of those. And when we start building these in real life, we will also need a breadboard. And we need an LED. So I'll bring an LED in. And of course, I need a resistor so my LED doesn't explode, because if you remember from our introduction to the Arduino video, our Arduinos run at 5 volts just like our power supplies did for electricity and circuits, and 5 volts is enough to make one of these LEDs go pop. We want to avoid that. My resistor, I still have my resistor options open, and it's asking me to input its resistance. I'm going to type in 220 and change kiloohms to ohms. Remember, you can pause this at any time to go do these steps on your own Tinkercad tab. Alright, so I have my LED, I have my resistor, and now here comes the big boy, the Arduino. I'm excited. This is the first time you guys get to use this. So I have my Arduino set up. Now, we want this light, this LED, just to turn on and off. That's a completely digital function. So that's on, that's off. And since our Arduino is going to send current out to the light, we would call that an output function of some kind. So I need to use a pin that can output current in a digital kind of way. And that's going to be one of these digital pins up here. For what we do in this class, we're never going to use pins 0 and 1. You can see that's TX and RX. That means transmit and receive. So these pins are really set up for talking to other Arduinos or anything that uses its special protocol there. So we're going to leave pins 0 and 1 alone pretty much always in this class at least. So we could start at pin 2 and we can go all the way up. Now, We can use a non-PWM pin like pin 2, or we can use a PWM pin like pin 3. Both non-PWM and PWM pins, they will get a light to blink in a digital kind of way. If I wanted my light to dim, like fade on and off, I would have to use one of the PWM pins like 3. But for this assignment, it doesn't so much matter which one we choose. So what I'm going to do is I'm just going to bring my LED to the breadboard here. Okay, let's get it on the long leg on 10. Now, as a point of practice, I always like to hook up my breadboard to the appropriate spot on the Arduino. For example, when we did circuits, we knew that this positive rail right here should always have a positive current. And if you remember the spot on the Arduino that always has a positive current, it's this 5V pin. So the very first thing I'm going to do is I'm going to attach the 5V pin on the Arduino to my breadboard. And since that's a positive current wire, I always like to make that red. And then the negative, right? If you remember, the negative is not called the negative anymore on the Arduino. It is now called the ground. And ground is the letters G and D. So I'm going to hook up my negative to ground, or my negative to GND. Okay, so that means that this rail right here has a positive connection, and this rail right here has a negative connection. The rails on the other side right now, they don't have any connection. So as a point of practice, I always like to just attach my rails together like this. So now I brought the negative connection over to the other side and the positive connection over to the other side. So now all of my rails, and oops, sorry for that accidental zoom there. All of my rails have the appropriate connection. We are not going to use the positive rail though to power on this LED. If I did do that, that LED would always be on. Let me show you. So I could bring current from the positive rail to my LED like that. And then I could force that current to go through this resistor back to negative after it goes through the LED. And if I click Start Simulation, that light is always on. And that's because this 5-volt pin that's sending out current to the LED right now, it is not programmable. It is always going to supply 5 volts of current. So if I'm always supplying 5 volts of current, that light is always going to be on. So I'm going to stop simulation. So we don't want this red wire right here. I'm going to delete that because I don't want my LED to always be on. Instead, I want one of my digital pins that can go on and off through a program to control this LED. So what I'm going to do is I'm going to click on pin 2, and I'm going to let pin 2 bring current to that LED. So this LED is not going to get its positive current from the 5-volt pin. This LED is going to get its positive current from pin number 2. And pin number 2 is kind of neat because we can write a program that controls it. So what I'm going to do, we're now going to look at how to write that program. Our circuit is all the way set up. Now we just need to get it programmed. In order to do that, I click here on Code. And whenever we start off with code, you'll see that we have some block coding. If you want to explore block coding on your own, feel free. For the things that we want to end up doing in this class, though, block coding isn't really going to work as well as we want it to. So we're going to switch from block coding to text coding. And it will give us a warning. Are you sure you want to switch to text coding? All of your block coding will disappear. I'm okay with that. We're going to click continue. And here we have our text code. And I'm going to just zoom that in a little bit there, make it a little easier to see on your screen maybe. And just kind of look at my circuit. So let's talk about what we know about our C++ code. We have our two functions. So you can see whenever I start a program in Tinkercad, it has the two functions that I need already there. So we could see a void setup section, and we can see that there's a function statement already in the void setup function. And we have the void loop section, and there's already several different function statements here in that. Because this stuff isn't going to do exactly what we want our program to do, what I first do is I kind of just delete all the stuff that's already there. All right? So I want to set up some variables, and I want to set up a variable that both functions can use. So if you remember, that's called a global variable. So I'm just going to put a space or two at the top by hitting enter. I'm going to take my cursor to line 1, and let's start creating some global variables. All right, I want to rename pin 2. And since pin 2 is controlling this LED bulb, maybe I do this. If you remember, I need to start with, and I'm going to flip back to my tab over here so we can see, I need to have a data type for my variable. So, and that we're going to talk today about the int, or the integer data type. Integer, if you remember, are those a whole number? Like pin 2 is a whole number, it's an integer. So pin number 2 would be an integer data type. So what I do, if you remember the structure for it, and I'm going to write 2 slashes. You don't have to write these 2 slashes. This is just a little note for me. The structure for writing a variable means I have to go data type, oops, space, variable name, space, equal sign, space, and then the assigned value. And then to end the function statement, I also have to end with a semicolon. All right, so I'm going to hit enter. This is just the structure or the syntax that a variable has to follow when I create a variable. So let's go ahead and call the data type, and that's an integer data type, which is int. And our variable name, well, what do I want to rename pin 2? Well, it's controlling this LED, so maybe I call it LED capital PIN. And if you remember from my last video, variable names can only be one word long. Since I'm trying to use 2 words, I had to squish them together with no spaces. And typically, again, you don't have to do this, but typically in programming, the second word you capitalize in your variable name. So that's why I capitalized the P in pin. All right, so I have int led pin. So I've got the data type. I've got the variable name. Now I need an equal sign. So I'm going to type equals. And now I need to assign it a value. And that value is 2 for pin 2. So I'm going to type the number 2. And then I close things off with a semicolon at the end. So there's my semicolon. All right. Now, void setup is like our from stuff when we were doing the modules in Python robotics. So I need to turn on that pin now, or get it ready to let the Arduino know what kind of pin it's going to be. So our command for that is pin, lowercase, P-I-N, and then mode. Remember, it's squished together. So the second word is going to be capitalized, M-O-D-E. So pinMode. PinMode says, hey Arduino, we're going to get a pin ready to go. So, and then I turn on my parentheses, or I type a parentheses, because it needs 2 arguments. The arguments that it needs is, first, we need to type the pin name. Well, that used to be pin 2, but we're not going to use the number 2 anymore because it's no longer called pin 2. We just renamed it to, up here, pin 2 is now the LED pin. So instead of typing 2, I'm going to type in my new variable, LEDPIN. So we're going to get the LED pin ready to be a certain kind of pin. So the second argument that it needs is we need to go, and you can also see this over here in our pinMode. So we've typed in the pinMode command, we've typed in the pin name, and now you can see the second argument is we need to choose, is this going to be an input pin or is it going to be an output pin? Well, since pin 2 is sending current out to the LED, that's going to be an output pin. So in all capital letters, I type output. And that is the end of my function statement, so I need to close it or end it with a semicolon. All right, and that's the only pin that we have here, so that's really the only thing that I need to set up. I'm just going to get us also in the habit of putting this in our setup every time, is the command for talking to a computer. That's serial with a capital S dot begin. So that means, hey Arduino, let's get ready to talk to a computer. And we're going to talk to the computer using this number 9600. And that's the only argument that serial begin needs. And so I end that with a semicolon. All right, so we've set up two things. One of these things we will actually use in the program. The other one, the serial begin, I just want you to start typing that in every program just so it's kind of a habit when we get to it. All right, now, our void loop. This is the main thing we want our program to do. And it's a loop, so we know it's going to do it again and again and again and again. And I have to make sure that I'm between my curly brackets, and that's kind of something too important. I should go and make sure that I did in my void setup. All of my function statements or commands, those belong between the open curly bracket and the closed curly bracket of these big functions. So, for example, I can't start typing my void loop code right here on line 11. It would not work. I need to type it right here on line 13 because that's between the two curly brackets. Well, what do I want my LED to do here? Well, if I pop back over here to my assignment page, well, you know, we want it to blink on and blink off. That means I need to turn it on and turn it off. The command to do that is this one right here. That's that digitalWrite. And so I'm just going to copy that. I'm going to bring it in over here, but I'm going to bring it in as a note. So 2 slashes and then Control V to copy. So this, again, is just the structure that the command follows. So we could see the name of the command or the name of the statement is digitalWrite, and it has 2 arguments. Number 1 is I have to tell it what pin we're going to digitalWrite, and number 2, I have to say if that pin is going to be high or low. And then, of course, I need to end this statement with a semicolon. So let's look and see what happens here. All right. I'll start off by typing digitalWrite. Okay. The pin name, well, it's pin 2. But I'm not going to type pin 2 because we renamed it to LED pin. And do I want this high or low? Well, high means we're going to send electricity out. Low means we're not. I want this light to turn on because it's going to turn on, then turn off, then turn on, then turn off. So I'm going to set that pin as high. So I just got my LED to turn on. And if I click Start Simulation, you'll see that my LED did turn on, and I'm very relieved that there were no program errors. So, but that LED is always on because that's what's in my loop. Turn on, turn on, turn on, turn on, turn on. I never said turn off or do anything like that. So I'm going to stop the simulation, and the command to get it to turn off is still digitalWrite. Except this time I'm not going to go digitalWrite high, I'm going to go digitalWrite low. So let's just see what that looks like. So I'm going to type in digitalWrite with a capital W, and then set the LED pin. This time I'm going to set it to low, all capital letters. Yeah, that's a real big important thing to make sure you're typing exactly like I type. All right, and I'm going to start simulation. Uh-oh. Well, it's not blinking on and off even though I told it to blink on and off. If you look over here, my LED just looks kind of dim. Well, it actually is turning on and turning off, but our Arduinos are very fast. We said turn it on and then immediately turn it off, and then it's a loop, so it goes right back to the beginning, and then it immediately turns it on again. It is turning on and off thousands of times a second. You can't even see it turn on and off, and that's why it looks kind of dim. The LED doesn't get a chance to get fully bright. So what we need to do is we need to add some commands in here that will get the LED or the Arduino to take a little bit of a pause. And that, if I look over here in my assignment page, is this delay command. So what I'm going to do is I'm just going to copy that, and I'm going to bring it over here. And again, I'm just going to put in a couple slashes and then paste it, just because this tells me what the structure looks like. Remember, if I start two things with slashes, that's like starting things with the hash mark in Python. It's just a note. My program will not run things with two slashes at the beginning. Again, you do not have to copy that over. I just copied this the slash stuff over so I could see the structure. All right. Well, I need to do this. I'm going to go here and I'm going to put, after I turn it on, I'm going to use this delay. So I'm going to type the command delay. And then you can see it only takes one argument, and that's number of milliseconds. Well, imagine that we take 1 second and we split it into 1,000 parts. That's a very quick amount of time. That 1,000th of a second is called a millisecond. Right? You've probably seen milli before, like in millimeters. So, if I want this to stay on for 1 second, I have to type in 1,000, because that means 1,000 milliseconds, that's one regular second. So I end the parenthesis, and then I give it a semicolon. So what's going to happen now, let's kind of read this program like the Arduino is going to. The light is going to turn on. We're going to keep it on for 1 second. The light is then going to turn off. And then it's immediately going to go back to the top of the loop, and it's going to turn on again. So I want you to notice that we told it how long to stay on. That's this delay 1,000. But we never told it how long to stay off. So I hope you figured this out by now, but we need one more delay command, and that's after off. So I'm going to go delay, and I'm going to type in 1,000. So now let's read this program. So it's going to turn on, and then it's going to pause for a second. Now, because the light's already on, that means the light stays on for 1 second. Then it's going to turn off and pause for a second. That means this LED will be off for 1 second. Then it will go back to the beginning of the loop, which is digitalWrite high. So it'll turn on, wait a second, turn off, wait a second. So let's see what that looks like. There we go. We have successfully completed assignment number 3. Get one LED to blink on and off. So, if you're in my class, do not forget to make this public. Do not forget to copy the share link and submit it to Canvas. Thanks for watching, guys, and congratulations on building and programming your very first Arduino assignment. Great.